Good morning, students. In the last class, we have discussed about the types of simple permanent tissues. Now, let us discuss about the epidermis of the plants and the complex permanent tissues. The word epidermis, it comes from two words, epi and derma. Epi means above and derma means skin. Like how our skin is present above the entire tissues of our body, in the same manner, epidermis is present on the entire surface of the plant body, and it is the outermost layer and it is single layer. Okay. It covers the entire surface of the plant body and it offers protection to the parts of the plant body. Right. And it forms continuous layer without gaps. In the epidermal layer, many cells are present. These cells do not have any intercellular spaces, so that it will form a continuous layer, so that it can form a thick sheet, okay, and without gaps. Why? If any gaps are left, anything from outside can enter into the body of the plant through those gaps. Since the role of epidermis is providing protection to the plant body from the outer environment, it should not have any gaps. So only it forms a continuous layer. And epidermis is generally made up of flat cells, and these flat cells have got three surfaces: the outer surface, the side surface, and the inner surface. The outer and side surfaces of the epidermal cells are generally much thicker than the inner surface of the epidermal cells. So, the outer and side walls are thicker than the inner walls. Plants live in various habitats. Some habitats will have good amount of moisture or moist soils, and some habitats will have only dry conditions. The plants which live in dry habitats are the plants that live in desert regions, generally are called xerophytes. In such xerophytic plants, the epidermis is generally much thicker than in the normal plants. In the xerophytic plants, the epidermis is much thicker than in the normal plants. If you take the epidermis, as we already have discussed, it covers the entire surface of the plant body. But plant body, some amount of plant body grows above the soil or above the ground, and some amount of the plant body grows underground or below the soil, which we generally call as stem and root respectively. Stem is also called aerial part of the plant body. Aerial refers the plant body that is exposed to the atmospheric air, that is aerial plant body. So, the aerial parts of the plant body, they contain the special epidermis which secrete a waxy layer, which is water resistant, because the outer surface of the aerial part of the plant body, generally it is getting exposed to various environmental pressures directly, like rain, heat, okay, cold, wind, etc. All these environmental pressures may cause some damage to the plant body. So, the aerial parts of the plant body contain the special epidermis which secrete a waxy layer. This waxy layer is water resistant as well as mildly skidding type. Because of this water resistant nature, the plant aerial parts of the plant body are protected from, because of this waxy layer, the aerial parts of the plant body are protected from three conditions. They are water loss, mechanical injuries, and invasion of fungi into the plant body. Invasion means entry into. So some fungi, they try to enter inside the plant body. Okay, and if the waxy layer is not there, water may be getting lost through the small pores that are present on the aerial parts of the plant body very easily. And if waxy layer is not there, because of many physical environmental pressures may cause mechanical damage or mechanical injury to the plant body. So having waxy layer which is secreted by the epidermal cells of the aerial parts of plant body protects the plant from water loss, mechanical injuries, and invasion from parasitic fungi. And coming to the epidermis of leaves. Epidermis of leaves, it is very special than compared to the epidermis of stem and roots. How? Epidermis of leaf, it contains special pores, tiny pores in them, which we generally call stomata. These stomata will help in the plant for their gaseous exchange and in transpiration. Stomata help the plant for their gaseous exchange, which is required for both photosynthesis as well as respiration and also for transpiration. Okay, right. And these stomata are covered by kidney-shaped guard cells. Stomata are generally covered by kidney-shaped guard cells. And stomatal opening and closing is the function of the guard cells. Stomatal opening and closing is the function of guard cells. Now we have discussed about the epidermis of stem, that is aerial parts of the plant body. We have discussed about epidermis of the leaves. Now let us discuss about the epidermis of the roots. Epidermal cells of the root, they have root hairs. Root hairs are long hair-like structures which are formed by single cell only. These long hair-like structures that are formed by single cells which are present on the roots are called root hairs. These root hairs increase the surface area for water absorption. These root hairs increase the surface area for water absorption. And in the case of xerophytes and desert plants, or desert plants, the waxy layer, it contains special substance which is called cutin. This cutin made layer is called cuticle. This cuticle is much thicker in desert plants. Okay, this cutin or cutin made cuticle helps these desert plants from especially water loss. Okay, right. Now, in the case of mature stems of woody plants, we see many plants like teak, mango, or neem, right, and tamarind, like many large trees. In those plants, in their mature stems, okay, the epidermis is replaced by a special tissue called carp or bark. Epidermis on the stem, it is replaced by a special dead tissue called carp or bark. This carp or bark, it is produced by the secondary meristem. The secondary meristem is the meristem which starts its functioning after a later period of growth in the woody plants. Normal primary meristems, we already have learned. Okay, previously meristems are of two types based on the time of their origin in the plant body. When the plant is germinated, during that time itself, two types of meristems are present: apical and intercalary meristems. These two meristems are called primary meristems, which help in vertical growth of the plant body. And after a later period, after some amount of vertical growth is achieved, in order to increase the proportionate girth size, lateral meristems are going to be developed. as they form as a secondary development. That lateral meristem is called secondary meristem. These secondary meristems help in the secondary growth, and the secondary meristem provides the plant, okay, this cork or bark. The cells of the cork or bark are dead cells, and they are compactly arranged, and they contain a special chemical substance called suberin. Okay, on the waxy layer, the substance that is present is cutin. In the cork and bark cells, the chemical substance which is present is suberin. This suberin is impervious to water and gases, so that whatever the waxy layer or cuticle was performing the function, more than that, this suberin made layer is going to perform. Means the plant will be protected from water and any invasion of fungi, all these things. Okay, the plant is protected from all certain things. Okay. Now coming to complex permanent tissues. Complex permanent tissues. They are xylem and phloem. As we have discussed already, simple permanent tissue is the one which is made up of only one type of cell. Only one type of cells. Whereas complex permanent tissue is made up of more than one type of cells. More than one type of cells. And these different types of cells, they are all different, but all together they coordinate with each other and carry out or perform the same common function. All these different types of cells which are present in complex permanent tissue, altogether they coordinate and perform or carry out same common function. And what are the complex permanent tissue? Xylem and phloem. Xylem and phloem, they are the conducting tissues, and both together they form vascular bundle. Vascular means transporting or conducting bundle. Okay. Presence of these vascular tissues enabled means made them to have the ability to grow successfully. Okay, presence of vascular tissues enabled the complex plants to successfully survive or grow on terrestrial environments or in terrestrial. Terrestrial means complete land environments, not in water. Okay, right? From the water, above the water, that is there is the ground. Okay, above the water level, above the sea level, on the ground, the complex plants are successfully grow because of the presence of vascular tissues, right? And what are the various structural features and functional features of xylem and phloem? First, let us discuss about xylem. Xylem is made up of four elements. They are tracheids, vessels, xylem parenchyma, and xylem fibers. Okay, and these have thick walls. The cells of all these elements are having thick walls, and tracheids and vessels, they are the tubular elements. Among these four elements, tracheids and vessels are the tubular elements, and they carry out water and mineral transport only in upward directions or vertical transport. So tracheids and vessels, they help in vertical transport. And parenchyma, xylem parenchyma, its functions are storing the food and helping in the sidewards transport. Sidewards transport means, see, in tracheids and vessels, upward or vertical transport is taking place. Whereas through xylem parenchyma, sidewards also water is needed, water and minerals are needed. So sideward transport of water and minerals is taking place by means of xylem parenchyma, right? And fibers, they are meant for only supportive role for these tracheids, vessels and parenchyma. And most of the cells of xylem elements are dead cells only. Most of the cells of xylem elements are dead cells only. Coming to phloem. Phloem is made up of same four elements. They are sieve tubes, companion cells, phloem parenchyma and phloem fibers. Phloem is made up of four elements. They are sieve tubes, companion cells, phloem parenchyma and phloem fibers. See here, unlike two things of xylem, in xylem tracheids and vessels are tubular elements. Here in the case of phloem, only sieve tubes are tubular elements, and they are even perforated also. Why perforated? Perforated means as they are transporting the food to the downward or upward direction, to the sideward directions. If food has to be transported, that will be done through the small pores that are present in the sieve tubes. And phloem conduct the transport both in downward direction as well as in upward direction. So phloem transport is bidirectional. Whereas in the case of xylem, water and minerals are transported only from downside to upside, from roots to stem only. So that is unidirectional. In the case of phloem, food is transported both in downward direction as well as in upward direction, but not at the same time, during specific times. At certain times only in downward direction, at certain other times only in upward direction. Whatever it may be, phloem is conducting the transport both in downward as well as upward direction. So phloem transport is bidirectional transport. And phloem transports the food from leaves to other parts of the plant. Phloem transports the food from leaves to other parts of the plant, especially to the roots in the normal season when leaves are present. When leaves are absent in certain plants, deciduous plants, the leaves will all get shed off during the autumn season. During the early spring, from roots, the food is transported to the top of the plant, that is upward direction. Okay. Now, among all these elements, sieve tubes, companion cells, phloem parenchyma and phloem fibers, only phloem fibers are having dead cells, remaining all elements are having live cells only. Unlike in xylem, wherein most of the cells of all elements are dead cells, whereas in the case of phloem, only the cells of phloem fibers are dead cells, remaining all elements they are having live cells only. Right? Thank you.